Okay, so we're still on chapter 5. Now we are going to do a 3-point cross. So we'll start with problem 1. This problem has 3 sections to it. So in the first section, we're going to determine the order of genes. In the problem, we have the sharing wings, CH, black body, B, and cinnabar result from recessive alleles that are all located on chromosome 2. A homozygous wild-type fly was mated with the shared black cinnabar fly, and the resulting F1 females were test-crossed with the shared black cinnabar males. The following progeny were produced by the test cross. So, in order to genes, I'm going to explain it a little further in the second part, but I already put the answer up right here of what our answer will be. The CH and the B will be located on the ends, and then the CN will be located in the middle. And then I'll go into how I got my answer. So here we're going to calculate the map distances, and that's also how I determined the order of the genes. So we're going to start out with CH and B plus. So 105 plus 40, CH, plus 41, CHB, plus 102, CH plus B. And then we divide that by the total, 1800, and I got 0.16. And then I did CN plus minus B plus. So I did 105 plus 4 plus 102 plus 5 divided by the total, and that gave me 0.12. And then I did CH plus minus CN plus 40 plus 4 plus 41 plus 5 divided by that total, 1800. That gave me 0.05. So you can see that the calculated map distances coincide with the gene order. We got 0.116, and so that was the distance for CH and B. And then we got 0.112, and that was the distance for CN and B. And I did map units, so you just move the decimal over to give it a total full number. And then we did the same thing, CH and CN, 0.05, which was 5 map units, CH and CN. And so this kind of gives you a visual of how it would look on, and I did it on a triangle. But as you can see that it doesn't add up. So 0.12 and 0.05 do not add up to 0.116. So when it doesn't necessarily add up fully, that's perfectly fine. Your answer is still correct. You just will have to calculate the efficient of coincidence and interference. Coincidence. I think that's correct. Okay. And so to do that, we do, for C, we do our observed over our expected. So we just, the observed that I chose were the two smallest numbers, 5 plus 4 over 1800 times 0.05 and 0.12. And then you can see that we got our 0.05 and our 0.12, which was the expected, from the calculations that we did right here, which were also the two smallest numbers that we had. So when you calculate that, you get 9 over 10.8, which totals out to be 0.83. But you have to remember to also subtract that by 1. So you do 1 minus 0.83, and you get 0.17. And that will be your total answer for the calculation of that, 0.117. And then we're going to move on to problem 2 on the 3-point cross. Very similar problems. First, we have to find what is the gene order, and the gene orders B and C will be located on the ends, and A will be located in the middle. And if you could determine that from this, but you also determine it from constructing the genetic map. So we do the same type of calculations. You do A and B, so 40 plus 10 plus 42 plus 14 divided by 1006 and got 0.105. And then I did it for A and C, and I did it for B and C. And then so that you could see how it would look on a map gene, I constructed a triangle. So B and A was 10.5. A and C is 22.1 map units. And then the whole thing, B and C, is 27.8 map units. And we know that because B and C are on the ends. So you know that they'll have the bigger map units. We know that A is in the middle, so the distance between A and C was 22.1, and the distance between B and A was 10.5. And that is how I worked out Chapter 5's problems with 3-point cross.